Hey guys, welcome to Crypto News, your daily source of info. Before we start this video, let me remind you that I am not a financial advisor. Remember to always do your own research before investing in an asset. Now let's begin. The Internet Computer Roadmap. Key development areas with pivotal milestones to move closer to the world computer vision. Definity. Follow. Published in The Internet Computer Review. 9 minutes read May 16, 2024. 410. 2. The Internet Computer went live on May 10, 2021. Since then, the network has upgraded itself hundreds of times, processed over 3 billion blocks, integrated with the Bitcoin and Ethereum networks, ran AI on blockchain as a contract for the first time in history, and broken so much new ground in the tech industry that it seems impossible that it has only been live for 3 years. This is the result of 1,000 years of R&D effort from some of the world's brightest and most creative minds. The Internet Computer aims to make blockchain singularity a reality. This means humanity's services and operations are reimagined and built on blockchain. The world in which the Internet Computer was born has changed, but the goal remains the same. The community's feedback and suggestions have played an integral role in creating and shaping this version of the ICP roadmap. The new and updated roadmap lays out 9 key areas of focus where the Definity Foundation will concentrate its efforts and deploy resources. These are 1. Compute platform, 2. Decentralized AI, 3. Chain fusion, 4. Privacy, 5. Platform decentralization, 6. Identity, 7. Governance and tokenomics, 8. Digital assets, and 9. Developer experience. Early community members will remember the metal-based milestones that led to Genesis. The milestones in this roadmap are designated by a name inspired by fusion technology. They reflect the ingenuity and bold ambition of fusion technology. Each focus area has 1 or multiple milestones. Dedicated teams will work on the milestones simultaneously, ensuring constant improvements and progress. Beyond the milestones, the roadmap additionally outlines future features that have not yet been distilled into milestones. While some of these features may be quarters or years away, they show the impressive ambition and vision for the Internet Computer. Each focus area is key to the success of the Internet Computer, and each milestone marks a significant breakthrough and opens up new opportunities for the blockchain community. This roadmap is not only for the ICP community, but for the blockchain industry as a whole. The Internet Computer can bring true decentralization, connect blockchains, grow communities, and solve AI's trust issue. Join us on this journey. The milestones. 1. ICP as a compute platform. Smart contracts are a superior way to build software, enabling secure, tamper-proof, resilient, and unstoppable applications. ICP's vision is that most of the world's software will be replaced by smart contracts. The goal of the compute platform theme is to take away any limitations of smart contracts and enable the world's software to run on ICP. Tokamak milestone. The first milestone of this domain, called Tokamak, is focused on reducing latency, which is key in providing a great user experience and achieving mass adoption. Tokamak achieves this by focusing on the networking and consensus layers. Concretely, by taking full advantage of the quick-base transport layer, it will maximize the block rate of every subnet. This milestone will also introduce a new synchronous ingress submission endpoint, avoiding latency wasted in polling to see if a message was fully processed. It will also make the boundary node route to replicas latency-aware. Stellarator milestone. The second milestone in this domain is called Stellarator, and is centered around working with vast amounts of data. This milestone will introduce a new storage layer, which will enable subnet blockchains to host over 1 terabyte of canister smart contract memory. Moreover, by further increasing the amount of memory each individual canister can use, larger amounts of data can be uploaded and processed by smart contracts. Stellarator will also contain key improvements to the consensus layer of ICP, boosting the throughput by reaching agreement on hashes of messages, utilizing the bandwidth of the node machines powering ICP more efficiently. 2. Decentralized AI. DEI involves running AI training and inference as smart contracts on-chain, which addresses AI's trust issues. Users can verify the inputs to the models they utilize, reducing the need to trust them blindly. However, AI training and inference are highly resource-intensive, and the limited computational capabilities of traditional blockchain networks often fall short. In contrast, the advanced design of the ICP successfully marries the security of smart contracts with the robust computational demands of AI. Cyclotron milestone. Cyclotron enables fully on-chain inference on larger models in canister smart contracts through performance improvements in the WebAssembly runtime and the inference engine. The improvements in WebAssembly include a significant performance improvement in floating-point operations, support of single-instruction multiple data commands that improve parallelism, and support of 64-bit memory for larger datasets. Together, these changes will enable fully on-chain inference on a larger set of AI models. Gyrotron milestone. Gyrotron will allow for AI inference and training of large models on-chain. Smart contracts need a way to run compute and memory-intensive computations on hardware such as GPUs. The main challenge of this milestone is to define a deterministic API for smart contracts to access and call GPUs. Additionally, adding AI-specialized subnets with nodes exposing GPUs to smart contracts will be explored. 3. Chain fusion. ICP enables direct interoperability with all major blockchains, including Bitcoin, Ethereum, and other EVMs, without relying on any trusted intermediary. ICP smart contracts can read from and write to different chains, enabling developers to write smart contracts spanning multiple chains. Tritium milestone. The first chain fusion milestone is Tritium. Tritium will allow ICP to interact with Ethereum and EVM smart contracts. To make this possible, this milestone will release the EVM RPC canister, making it easy to write ICP smart contracts to interact with Ethereum mainnet and EVMs. Chain key signing is a crucial part of the chain fusion technology, and this milestone will include latency and throughput increase to the chain key ECDSA functionality of ICP. Finally, this Tritium will include CCUSDC, a twin token of USDC on Ethereum, built on chain fusion technology. Deuterium milestone. The second chain fusion milestone is called Deuterium, which is all about Bitcoin. While chain fusion already supports Bitcoin in general, some emerging new protocols that extend Bitcoin are not fully supported yet. With Deuterium, chain fusion will fully support them with two main developments. First, the chain key signing functionality will be extended to include Schnorr signatures, which enable canisters to make new types of Bitcoin transactions that are required for these protocols. Second, the Bitcoin integration will be extended to give access to all Bitcoin block headers, allowing canisters to securely read and verify messages of these emerging Bitcoin protocols. Helium milestone. The Helium milestone enables chain fusion for the Solana network, bringing Solana and ICP closer together, combining the powers of the two networks. dApps leveraging the capabilities of both networks look and feel like single network dApps. 4. Privacy. Canister smart contracts can be used to implement privacy-preserving dApps that give users full control over their data. Leveraging cryptographic protocols, ICP enables developers to build dApps where users store and share encrypted data on-chain. Advanced cryptographic protocols will eventually allow computations on encrypted data. Niobium milestone. The Niobium milestone is about verifiable encrypted threshold key derivation, called vetkeys. Vetkeys enables dApps on ICP to securely encrypt user data securely and ensure that no unencrypted data ever hits the blockchain. All encryption and decryption operations are performed directly on the user's devices. Vetkeys also enable additional functionality, such as maximal extractable value (MEV) protection in DeFi transactions using threshold encryption, or improved privacy for internet identity. The developer preview of the Vetkeys API has been live since mid-2023. Niobium will complete the implementation of the protocol and provide canisters with access to a secure production version of the API. 5. Decentralization. The security of ICP is based on the elimination of central points of control. A user interacting with ICP will not need to rely on a single party. Besides architectural aspects, such as the edge infrastructure, this also encompasses operational aspects, complementing the DAO-based governance of ICP. Solenoid milestone. The solenoid milestone decentralizes the operation of the ICP boundary nodes. At the moment, nodes controlled by DeFinTi perform the following functions: routing requests to the relevant subnets and caching results, translating between the HTTPS protocol expected by browsers and the ICP protocol used by canisters. Solenoid will split the role of the boundary nodes in two. API boundary nodes, which take the roles of routing and caching, will be under the control of the NNS like replica nodes. HTTP gateways, which serve content to browsers, can be set up and controlled by anyone, leaving the choice of a trustworthy gateway to the user. Levitron milestone. This milestone establishes visibility into the Internet computer's edge infrastructure by making aggregated API boundary node access logs publicly accessible. This provides developers with valuable insights into their dApps usage patterns and facilitates the generation of user statistics, offering key information on traffic sources. To guarantee the integrity of these logs, the milestone focuses on leveraging trusted execution environments, specifically AMD SSN and 6. Identity. An identity solution that is privacy-preserving, self-sovereign, and user-friendly is a fundamental building block for Web3 adoption. Internet Identity provides a robust authentication solution based on passkeys, with easy onboarding and support for identity attributes while protecting the user's privacy. Separatrix milestone. Separatrix introduces verifiable credentials and identity attributes. Internet Identity has been the primary authentication solution for ICP since its launch. Until the Allocator milestone, a user authenticating with Internet Identity to a dApp is assigned a per-dApp unique and pseudonymous identifier without any additional attributes such as name, age, or residency. Separatrix introduces a verifiable credentials framework that allows a user to assign identity attributes to their second. dApps can take the role of an attribute issuer, meaning that they assign a certain attribute to a user's identity, or as an relying party, meaning that they consume an attribute assigned to a user's identity. The ready availability of token payments on ICP enables the creation of an identity ecosystem, in which attribute issuers can be rewarded for any potential verification they perform. 7. Digital assets. DeFi protocols, real-world asset tokenization, and other digital asset solutions are strong drivers of Web3 adoption. ICP's chain fusion capabilities, unparalleled scalability, and the ability to serve web assets from chain opens up novel digital asset classes. Moreover, it makes ICP an attractive platform to build multi-chain custody solutions and wallets. Toroidal milestone. The toroidal milestone is centered around Oizy, a wallet with a unique combination of properties. It is the first smart contract wallet that is fully accessible through the browser, while also being self-custodial, multi-chain, and easy to use. Oizy uses passkeys for authentication, making it secure, but without requiring seed phrases and passwords. Oizy supports ICP-based dApps through ICRC21, EVM-based dApps through Wallet Connect, and easily converts between native Ethereum tokens and their CK twins. Poloidal milestone. The Poloidal milestone is focused on Orbit, a comprehensive digital assets framework, enabling simple to advanced rules over user digital assets. Initially tailored for token management, it provides robust support for 1 out of M to complex approval policies for financial transactions. It also supports secure management of infrastructure like canister installations and upgrades. Teams and businesses can confidently handle ICP, CKETH, and compatible tokens using Orbit's advanced security features, vital for those seeking a stable and reliable management over their treasury. 8. Governance. ICP has two kinds of built-in governance systems. The NNS is the DAO governing the ICP protocol. The SNS framework is a toolbox for creating DAOs that govern individual dApps. Both are open for everyone to participate and facilitate decentralized decision-making. Tokenomics incentivize voting participation and ensure that DAO decisions are aligned with the long-term interests of the ICP and the governed dApps. Plasma milestone. Plasma advances the decentralization of liquid democracy on ICP. In liquid democracy, voters can choose to either cast their votes individually or follow experts they believe will make the best decisions. The goal of Plasma is to broaden the set of experts that cast their independent vote on proposals that are vital for maintaining the integrity of the ICP network. 9. Developer experience. Developer experience is an essential ingredient for developer adoption. This includes low-friction canister development and operations, expressive smart contract languages, testing frameworks, and a rich set of libraries. Beyond canister development, developer experience also encompasses an inclusive and quality-preserving protocol development. Beryllium milestone. The Beryllium milestone is heavily influenced by developers' requests and feedback. Beryllium provides substantial simplifications and improvements for the developer's lifecycle of canisters, particularly regarding their development and operations. Snapshotting capabilities, a powerful logging infrastructure, and improved error handling, as well as insights into the cycle's consumption of canisters and push of relevant events brings canisters closer to Web 2 services in terms of DevOps. The Internet computer has rapidly evolved since its launch in 2021, demonstrating significant advancements in blockchain technology. With this updated roadmap, Dfinity is charting a course to ensure the world computer vision is achieved. A key factor to the success of the Internet computer is the ICP community. We want to hear from you. Please share your feedback on the roadmap. Which features are missing? What milestones will you benefit most from? You can submit and upvote feature requests on the DX feedback board, or engage in the discussion on the forum for other feature requests. We look forward to hearing your ideas and making this another successful year for the Internet computer. Written by Dfinity. The Internet computer is a revolutionary blockchain that hosts unlimited data and computation on-chain. Build scalable Web3 dApps, DeFi, games, and more. Thank you for watching. Make sure to subscribe, like, and share for more videos.